All right, so today we're going to continue our look at 9H, the box plots, but we're going to talk a little bit about a special condition that can happen, and that is what happens when you have outliers. So the last assignment that we did, all of the problems at the bottom said there are no outliers, but there can be in most data sets. Say, for example, we're going to look at how long each one of you studied. So that would range from probably 0 to an hour. And then you would have somebody who did 10 hours of studying, right? So you see that there's one person who would do way more or go beyond what's normal for the group, right? So those things, those outliers can't be included in your data set. All right, so pieces of information that don't fit within the group are called outliers. So outliers are simply data that is not like the mass of data. So very far removed from the interquartile range and actually going further out than the whiskers. Now this data still exists, and we still have to put it in our our box plot, but we want to make sure that we can point to these as outliers. In other words, they're not changing our interquartile range or any of the other pieces of information. You can still have box plots with long tails on one side and not have outliers. So what we need to do is we need to test to be able to see what outliers there are and how to do that. And luckily for you, the formula for testing for outliers is on your formula sheet. So you don't have to memorize it, but you do have to use it. So let's just pop over to the formula sheet and talk about the pieces. So if you look at the very bottom of the statistics formula sheet there, that you will have on the test, you'll see that you have two different outliers that you can have. You can have outliers that are below the first quartile or below the minimum, and then you can have above. And these are called the lower fence and the upper fence. Anything that falls outside of those ranges will not be included in your box or the tails, the whiskers. Instead, what you'll do is you'll simply put a dot to represent each of those pieces of information. If you have them, there usually aren't very many of them. So notice the first one, because we're going below, you're going to be subtracting. So it's Q1 minus 1.5 times the interquartile range. And again, remember the interquartile range is just Q3 minus Q1, right? You need to find that anyway. And then when you're looking at the upper fence, the only difference is that you're using addition there. And again, you don't have to memorize them, but you do have to use them. So this is telling you, because X stands for all your data values, it's telling you that in order to be included in the box plot, your data has to be between those two values. Okay? And what happens is sometimes that's going to exclude some of your data values. They're going to become outliers. Now you still have to graph them, but you don't have to put them, but they won't be inside the box plot or the whiskers. So let's just look at a quick example so you can see how this works. Everything else about the box plot stays the same. So again, outlier is simply something that doesn't fit, is different from the other observations. Okay. So if you look at this particular box plot, you can see that here you have your box plot, and here there are 3 outliers. And how they knew they were outliers is they used the formula to determine a fence. Then any data that fit within the upper and lower fences, they included in the box plot. Anything that fit outside, you just put a dot. Okay? All right. And again, you can see how they got them. It's either add to Q3, multiply by 1.5 times your IQR for the upper fence, and because you're doing the lower fence, you would simply subtract. So here we go. So the number of hours that each of 33 students spent on a school project is shown below. Construct a box plot for the data set to identify all possible outliers. So first of all, remember that your first thing you want is the 5-number summary. So you're going to do the minimum value and the maximum value. Then you'll find the median, and all they're doing is using that formula to show you the location of the median. So in this case, it was the 17th number, and they're already put in order for you nicely. So the median was 71. Then they found Q1 and Q2, the median of the bottom set and the median of the upper half. And then they determined the IQR. So the IQR is just simply Q3 minus Q1, gave you a value of 84. And then you could use that 84 to find the upper and lower fences. You could see Q1 minus 1.5 times the 85. And here they're finding the upper fence. So they just do the same exact calculation, except you're adding it. All right. Once you have those fences, you just go back and realize that there's one outlier, 264, so that was your maximum, right? So that's no longer your maximum. Then the largest value that is not an outlier becomes your new maximum, right? Because 264 was out of your range. So then you can create your box plot and notice that the outlier, that piece that was beyond your range, above your upper fence, is just represented on its own as a dot. All right? So, again, the only difference is you need to check for outliers on the ones that we do today. And that's it.